Hi, I am Yaman HAS.
Hi, I'm Ceren ZOR. Our project is LIFESAVER detector.
Earthquakes are natural disasters that have had very painful results in human history. It's not possible to prevent the occurrence of earthquakes or to determine the time they will occur. It's possible to minimize the damage and loss of life, especially after the earthquake. We thought of designing a device to shorten the rescue time of the people who were buried under the wreckage as a result of these earthquakes. The problems we identified accordingly: reaching people and animals under the wreckage in the shortest time, not being able to detect the people or animals under difficult wreckage conditions, and the disadvantages of currently used devices.
We designed this device to reach people alive in a short time by determining the heartbeat and respiration of the people who are under the rubble even if they were inactive. So what's an earthquake? An earthquake is the shaking of the earth by vibrations caused by breakage or rupture events occurring in the earth's crust.
Here we see the earthquake risk map in the world. According to the researchers, the probability of people's survival under the wreckage in the first half an hour is 91%. This rate decreases to about 7% at the end of the fifth day. The average survival time under wreckage is 5 to 6 days. And search and rescue dogs, acoustic signals, and human physical search and rescue are the main methods used to locate victims. Now, we have listed some devices for detecting life in earthquakes and their advantages, disadvantages. Seismic acoustic listening devices, advantages. It's possible to perceive the signals produced by victims as visual and audio, but their disadvantages: it cannot detect victims who lost their consciousness. Its use is limited in noisy environments.
Radar life detection systems advantages: it can perceive life signals of the victims without physical contact throughout the holes in the construction, even from a long distance. But disadvantages: penetration depth is limited, can't directly pass throughout the wreckage.
You can see the other devices, advantages, disadvantages.
An example of a seismic acoustic listening device is the DICE Life Detector LD3. The DICE Life Detector LD3 transforms the entire collapse detector into a large and sensitive microphone that transmits sounds from disaster victims.
Also here, DKL Life Detector gives an example of radar detection devices.
The LIFESAVER detector comes to the fore with its sensor, microcontroller, and software. In our project, we use Raspberry Pi as a microcontroller. Our sensor doing non-contact breath following. It measures the distance between the person and the sensor. It can measure day and night regardless and measure respiration rate.
The Python was mainly used in this project. So we did our research. So what are the methods we follow in this project? Some tools and equipment were used in this project. These are briefing sensor, microcontroller cards, LCD display, and our power bank. We firstly determined the objects and tools we used in our life detector. We made the 3D drawing of the parts that will form the main body. After we assembled our device, we tried to determine the most suitable and most useful software for our life detector. While doing this, we considered the number of libraries and platforms it provides to other languages and practicality. In this direction, we made it using Python language, which is one of the languages that work most efficiently with the Raspberry Pi.
We created the outer body in order to keep the parts of the device together. We preferred an exterior design that the user can easily grasp and use when entering the rig. There's 3D photo you can see above and the photo of the printout below. As you can see there, we prepared the prototype and that's our device on the bottom.
And I want to show you now our device, and I want to tell you working principle of the device. You can see our device's main body. These are briefing sensor, Raspberry Pi, and the LCD display. These sensors has a transmitter antennas and receiver antennas. Transmitter antennas sends electromagnetic waves, and these electromagnetic waves bounces from the persons and detects from the receiver antennas. And you can see the white cable. This white cable provides the communication between sensor and Raspberry Pi. Raspberry Pi processes the data coming from the sensors, and we can see the victim's display, distance, heart rate, and respiration rate in the monitor. And the researchers have been done a specific method was followed in this project. So what are the findings we detected in this project? First of all, we placed our device and carried out single person measurements without obstructing it. As you can see in the table, the person was detected where the peak of the wave rose. Also, let's say that the wave amplitude changed according to the respiration, heart rate, and the movements of the person in the places where the wave you see in these graphics. That is where the device perceives the person.
Measurements for two people, which we measured without disabilities, are given here. Out of the peak decreases after 3 meters, the position in general is clearly visible on the graph. There are measurements of 3 people that we measured without using barrier are given here. It has been observed that the sensor can accurately detect the position correctly.
As you can see in the pictures, a 5 centimeter barrier was used in our next measurement, and the sensor was positioned 20 centimeters away from the barrier. As seen in the table, we see that the signal decreases when the barrier is placed and away from the device. We see that the waves peak at the point where the device detects the barrier, but let's say that this peak remains constant. The peaks that occur in detection of a person vary according to the respiration, heartbeat, and the movements of the person.
We used 8 centimeter thick barrier in these measurements. The sensor is 20 centimeters away from the barrier. In the first picture, we only see the change created by the barrier in the measurements. We can also observe that the peaks decreases depending on the distance. Here again, we see 2-person measurements made using an 8 centimeter thick barrier. As you can see, the waves peaked in places where people were present. In other words, our device has detected the person correctly.
In our next measurements, a 17 centimeter thick wall used and the sensor was again positioned 20 centimeters from the barrier. Measurements were carried out in 1 person. As can be seen, the signal loss has increased compared to other barriers. It was observed that as the thickness increased, the signal decreased in direct proportion, but again the sensor was able to successfully detect persons.
Here too, we see the measurements of 2 people standing behind the 17 centimeter thick barrier. There is a distance of 20 centimeters between the barrier and the sensor. Thanks to the screen located on the prototype of LIFESAVER detector, the distance of the person to sensor can be seen. In measurements taken from the computer, the distances corresponding to the peak points formed in position where the person is located are numerically on the screen on the LIFESAVER detector prototype.
Based on these measurements and researches, some results have been reached. While there were no barriers in front of the device, measurements were taken with 1, 2, and 3 people. It was determined that the device correctly detected the distance of the person from the sensor, and the amplitude of the wave increased or decreased according to the distance, movement, and respiration of the person from the sensor. Barriers of 5, 8, and 17 centimeter thicknesses were used. Also, the thickness of the barrier increased, the sensor can detect the victim at different distances. It was determined that as the thickness increases, the signal weakens a little, and the range at which it can give clear results decreases to 1.5 meters. For the 17 centimeter barrier,
It's about the connection, I guess. He will come right now.
my internet connection is has a mistake. Did you see the presentation? No?
Yes, we can see.
Okay. Methodically, research was done, measurements were graphed, and some suggestions were made from the project to be better. The device can be used not only in earthquakes, but also in mine dams, explosion dams, and so on. Different applications can be made in other sectors, such as health sector, construction sector, by adding different sensors to the device. With a larger budget, the range of the device can be expanded by using more sensitive sensor. The device can detect not only the distance of the victim, but also the probability of survival of the victim by checking the frequency of breathing.
LIFESAVER detector has easily applicability. It gives clear and reliable results to us because this device can't detect inanimate objects, and it's original. You can also use on mining dams or health sector by improve the device, and therefore our device stands out.
Here are the bibliographies we used in making this project. You can also the bibliographies in here.
And thanks to listening.
us.
Thank you for the presentation. Any questions from our experts?
Okay.
Could you explain the detector? What the physical value it detects? Sound or air moving? What is the detector?
Yes, our device works with electromagnetic waves principle. It's when meets the constraint blocks or any disabilities, these electromagnetic waves, some of the parts, these electromagnetic waves absorbing from the disabilities, but some of the parts, this electromagnetic wave passing through the wall and detects from the victims. Bounces and detects from the receiver antennas. You can see there are sensor antennas. This is a sender and this is a receiver. It's not used sound wave.
Sorry, I didn't understand it well. So the patient, I don't know how we could call this, the victim, does he need to keep some device with him?
I don't understand.
Should the victim keep something with them? I don't know.
No. The device detects the locations with electromagnetic wave system, but it detects the heartbeat of the person. So the victim don't need anything about it.
Electromagnetic waves. And
yeah.
What is the wavelength of this electromagnetic waves? What is the length of these electromagnetic waves?
We can reach this because of the sensors. We can't reach them to intent. We tried, but they detect
Understand? You use it as it is, as
Yes.
ready to use detector.
Yeah.
So it detects electromagnetic waves of body.
Yes.
Of human body.
And detects from the device.
Yes.
Okay. Thank you.
Can I ask another question? It looks similar to Teplavisor. Did you tested some alternatives? And the next question is, what can disturb your signal? For example, what else can produce the same signal? In what cases you can be mistaken?
I can answer the second question.
Yes.
We did our measurements on the different places. We don't problem in here because of the systems prototypes. I'm sorry, my English is not good. But we You, Yaman. I can't translate it. I'm sorry.
Can you repeat the question? Can you repeat it, your question?
Yes. What else can produce the same signal like human body? I mean, for example, using your detector, you can detect something else, not a human.
Okay.
We have a
Our
time.
our device detected the barriers, but barriers is a how can I say? You can see our findings. I will show you.
We have time only for a brief answer. Sorry.
What?
Time is over.
Short answer, please.
This is the obstacle, and this is the living things, and this device detects the barrier, but this wave remains constant. When detects the living things, the device, this wave, these waves. How can I say, change to the depending on the people's or victims' heart rates, movement, and the respiration rates.
Okay, thank you.